something called U-Substitutions. So I told you before that chain rule, when you guys learned chain rule, it was super, super important. And every year I have someone that's, absent on the chain rule day. And then it seems like they never catch up because we use the chain rule all the time. So this is the lesson that if you're ever absent for, it's going to be a disaster. So you guys are all here today. Yay! So you need to really, really pay attention to this rule because we're going to use it every single day for the rest of the year. Okay? It's the opposite of the chain rule. So this is called U-Substitutions. So when you see something like 2x times the square root of 1 plus x squared dx, we want to know how to integrate that. So we know that if we had a function, an original function, that looked like this, we need to know how to take the derivative of it. And if you guys remember, we did the chain rule, right? So we're going to go in the opposite direction. We're going to use the chain in order to integrate. Okay, so what we do, I used to do a whole long explanation of why this works, but I'm just going to show you some examples. Are we ready? What we do is we look for a part that if we were taking the derivative, we would usually involve the chain. So what's the part, if I was taking the derivative of what's inside, where would I need a chain? With the square root of 1 plus x squared, right? So this inside part is going to be my new variable, u, 1 plus x squared. Kind of like W substitutions in algebra 2. Fun, fun, fun. All right, now we do du. So now we take the derivative of u. Now, technically, I would typically write this as du dx, but I'm going to shorthand it, and I'm going to write du is equal to 2x, and then I'm going to tack on the dx on the right-hand side. It's like I'm breaking up that du over dx. All right, now if you notice in the above integral, we had 2x dx. That is now being replaced with du. Okay, what about the part that was inside the square root? That's being replaced with u, right? So everything's being replaced. So now we rewrite, and it's going to be the integral of the 2 dx was replaced with du, and the square root part was replaced by the square root of u. Okay, do we know how to integrate that one? Yeah, sure, because that's really just u to the 1/2, right, du. So when we integrate, it's u to the 3 over 2, add 1 to the power, do 1 over that new power out front, so 1 over 3 over 2 is really the reciprocal of 3 over 2, so 2/3 plus c. And then the last step, just like W substitutions in algebra 2, we were trying to get everything in terms of x, right, not u. So what's our last step? What do we do? Take that u and replace it again, right? So it's like, what was u? U was the 1 plus x squared. So we put it back in. That is our final answer. Okay, and the nice thing about this is you can always check. If you aren't sure if the U substitution worked, then let's just do a quick check step. If I let y equal my 2/3 times 1 plus x squared to the 3 over 2 plus c, let's think about how we would do the derivative, right? I would have my 2/3. I would then multiply by the derivative of 1 plus x squared raised to the 3 over 2. So I'd have times 3 over 2. 1 plus x squared, subtract 1 from the power 1/2, and then the derivative of c is 0. Does this work out to be what was in the inside of the parentheses to begin with? Oh, I forgot my chain, didn't I? Times my chain. That's what I was doing this for a reason, to show you the chain rule. So times 2x, and then the derivative of c was 0. So we get 1 plus x squared to the 1/2, which means it's under a square root, times 2x. Was that part what was here? Yep. Do you guys see how it's the opposite of the chain rule? Did you get it? Okay. So we're going to do several examples of this. Are we ready? All right. So the way that this is written out, and you'll see this on the AP test a lot, is you're going to see things that look like this. Okay, and you're going to realize that you have a function. You have f of g of x, so f of something in parentheses. Like we had the square root part that was kind of like in an invisible parenthesis, right? So you're going to have f of another function, and then you're going to have g prime of that function. Okay, so let's recognize, what is my inside function on number 1? What am I taking, what would I normally need the chain rule on? X to the 5th minus 4. Do you have its derivative somewhere? Kinda, right? You don't quite have it. You don't have 5x to the fourth, but do you have x to the fourth? Yeah, so let's let our u be x to the fifth minus 4. And then du is going to be 5x to the fourth, and we're going to put that dx next to it. So when we look up here, we're like, oh, that's almost it. We have x to the fourth dx.
It would be du over 5.
Exactly. So we take that 5 and we divide it over. So I write it as 1/5 du equals x to the fourth dx.
Why would you do that?
Because we want to get exactly what we're trying to replace. We're trying to replace, so this is going to be the sine of u part. Right? You see the sine of u? So that's going to be sine of u. And then everything that's not accounted for, we need to replace. So that x to the fourth dx needs to be replaced by something. So what is it equivalent to? Well, it's the same as 1/5 du. Okay? So when we rewrite, we have our sine of u, that's the blue part, right? The sine of u is what was circled or boxed in. And then we had x to the fourth dx. Well, that's replaced with 1/5 du. So we're going to put the du on the end. And the 1/5 I could sneak in front of the sine of u. I could put it next to the du. It doesn't matter. I always put it out front, right? Because constants can be pulled to the front. So we have 1/5 sine of u. Do we know how to integrate 1/5 sine of u? Yeah. So what's the antiderivative of sine? Yeah, negative cosine. So I'm going to have negative 1/5 cosine of u plus c.
So does the du serve as like, so if you're saying like 1/5 d, does that serve as saying like 1/5 x?
The du is the part that we need for the integration. Remember, it's telling us what variable to do.
So do we not, so we wouldn't do product rule?
With the du part, is that what you're saying? No, yeah, no product rule with the du part because it's just, remember, every time we write an integration sign, we always need like dx something, like dx, du, dj, it could be anything. So in this case, it's u. We changed it.
In u to the cosine.
So we're going to have negative 1/5 cosine of x to the fifth minus 4. That was the u, right? Plus c. Done.
What did you do with the x to the fourth out in front?
X to the fourth. I replaced x to the fourth dx. Right here, x to the fourth dx with what it was equal to, 1/5 du. So we'll have 1/5 du, and then the sine of u part was there.
So, but I mean,
So this was the part that was replaced by the blue, and this was the part that was replaced by the red. So the x to the fourth dx is the same as 1/5 du, right? And then the blue part was the sine of u. All right, so let's try the next one. So think about what your u is, try to find your du, and so on. Take you with me. So we're going to let u be 4x minus 5, and then du is going to be 4 dx. So look at your original integral. Think about what we're replacing. So this square root part is going to be replaced by the square root of u. The only thing that's left is dx. So we need to replace the dx with something with du, right? So when we look at what dx is equal to, it's equal to 1/4 du. That's what we're going to replace it with. Does this make sense? So when we do this, we're going to have the integral of the square root of u, and then the dx is replaced with 1/4, which I'll put out front, and then du. So we're going to write 1/4 the integral of u to the 1/2 du. So when we integrate, we get u to the 3/2. We have a 2/3 from that, right? 1/3/2. And we still have our 1/4 from before.
Is there a du in there? Or
There was when you did the integral.
you have 1/6 u to the 3/2 plus c.
So we had 2/12, which is 1/6. And then our u we can replace. So our u was 4x minus 5. So we have 1/6 of 4x minus 5 to the 3/2 plus c. Everybody feeling good about this? All right, so let's try the next ones. So it does get a little harder, so keep trying these along with me. Be active note takers, try the problems, see if you guys understand. Okay, so again, think about what you're going to let your u be. So what's your first guess? What do you think? Yep. And why do I not do like the square root of 1 minus 3x squared? Do you guys see why that makes it like way more complicated if you do the square root part? Because then you have like the chain for the square root as well. So it's always the inside part. So it's going to be 1 minus 3x squared. So then du then is going to be negative 6x and then dx. All right, so we want to replace, so the square root part's being replaced by the square root of u, so that part's good. What's left is the x dx. So that's right here, x dx. So I'm going to divide that negative 6 over, so I'm going to have negative 1/6 du equals the x dx that I need.
But x and dx are both in two different locations, so how can you use
They're basically on the same line. It's like a fraction. Like if I had 1/2 times 3, those would both be on the numerator. You can put the dx on the top or on the side. It doesn't matter. All right, so here we go. So I have the integral of, my bottom part was the square root of u, right? So I'm going to do 1 over the square root of u. And then my x dx is replaced with the negative 1/6 and the du. So I get negative 1/6, and I have the integral of u to the negative 1/2 when I rewrite it, so I can take the antiderivative. So it's going to be u to the positive 1/2 with a 2 out front, and then times that negative 1/6 from before, plus c. So we get negative 1/3, our u value raised to the 1/2 plus c. So our u value was 1 minus 3x squared. And you can check if you take the derivative of that, you end up getting the same thing that was inside the integration symbol. Now the next one, I feel like some of you guys are going to be really good at doing sine, cosine, tangent, all of those different things without writing the step with the U-substitution. I'm fine if you guys get this process. So think about when you take the derivative of like cosine of 4x. So if I had the derivative of cosine of 4x, I would get negative sine of 4x times 4, right? I'd have the chain. So how do you think this is going to undo the chain? What are we going to have when we do the antiderivative? Yeah, we're going to have a 1/4 up front. Do you guys see that? So let's write it with the U-substitution so you can see it. So we have u is equal to 4x. So du then is equal to 4 dx. So then all we have is this part's replaced with the sine of u. And so we have dx that we want to replace. So I have 1/4 du is equal to dx. So when I rewrite my integral, it's going to be the integral of sine of u.
So it's not x dx?
The derivative of 4 was 4x was just 4, not 4x dx. You see it?
Oh, that just...
And then the dx is replaced by that 1/4 and then the du. So the antiderivative of sine, remember the derivative is cosine, so the antiderivative is negative cosine. So I'm going to get times negative cosine of u plus c. So I'm going to have negative 1/4 cosine of 4x plus c. And you can put the 4x in parentheses or leave it out, it doesn't matter. Like negative 1/4 cosine of 4x, put the 4x inside parentheses or not inside. Good? All right. All right, so let's try with numbers, definite integrals. So there's 2 ways to do this. So I'll show you method number 1, method number 2, and then you can decide which one you like the best. I have a preference. We'll see if you have a preference. It doesn't matter. So it says when evaluating definite integrals, you can do 2 different things. So number 1, it says change the integral into u and du, and then convert back to x before plugging in your a to b values, your limits of integration. And number 2 says change the integral into u and du, keep the u's, and change the limits of integration into u values. Okay, so here's what goes on with this. So method number 1. So I'm going to ignore the 0 and 4 for right now, and I'm just going to do an indefinite integral. So I would say, okay, my u is 2x plus 1, my du is 2 dx. So I'm going to have my 1/2 du replacing the dx. So it's going to be the square root of u du with a 1/2 out front. Which when we integrate, right, our u to the 1/2, when I integrate that, I get u to the 3/2 with a 2/3. So I'm going to have 1/2 times 2/3 u to the 3/2 and plus c. You can write the c if you want. So you get 1/3 u to the 3/2. So 1/3 2x plus 1 to the 3/2 plus c. We would then say, oh, but we have the integral from 0 to 4 of the square root of 2x plus 1 dx. So these were our x values that we were going from. We were going from 0 to 4 for x, right? So we take our antiderivative from here, and we say, okay, well, I have 1/3 2x plus 1 to the 3/2, and I'm going to go from 0 to 4. And then you just do it normally. Yep. So you're going to plug in 4. So when you plug in 4, you get 2 times 4 is 8, plus 1 is 9. So you're going to have 1/3 of 9 to the 3/2 minus 1/3 of 1 to the 3/2, right, when you plug in 0? Are you guys getting good at your, like, 9 to the 3/2? Some of you guys came up to me during the test and were like, how are we supposed to know how to do this without the calculator? And I was like, oh, you should know this. So do you know it? Yeah, it's 27. So the square root of 9 is 3. 3 to the 3 is 27.
And then you divide it by 3 again.
So you have 1/3 of 27 minus 1/3. So it ends up being 26 over 3. So that's the first way. Okay, so some people kind of shortcut it. Like this, you could write your 0 and 4, but it's kind of bad notation, so sometimes they'll write u of 4 and u of 0 there. So we'll talk about that. So here's personally the way that I like. So choose your battles, I guess. I don't know. If you like this way, you can do it. So I like to start it out the same way with my U-substitution. So I'm like, okay, u is going to be 2x plus 1, and du is 2 dx. So I'm still going to have that 1/2 du equals dx. And we replace. So we're like, okay, I got my 1/2, I got my square root of u, my du, looking good. But I put numbers here. But I don't put 0 and 4, because 0 and 4 were x values. Okay, I want u values here. So who has a guess as to what those numbers are going to be?
Plug in the 4 and the 0 to 2x plus 1.
Yeah, so if I find u of 4 and u of 0, and I plug it into here, u of 4 is going to be 2 times 4 plus 1, which is 9. And u of 0 is going to be 2 times 0 plus 1, which is 1. So Charles is right. It goes from 1 to 9. Those are u values. Now we integrate just like normal, but we keep everything in terms of u. We never go back to x's because we've changed those numbers into u's, so we're going to keep them as u's. All right, so I'm going to say when I integrate this, I get my 1/2. I'm going to have u to the 3/2 with the 2/3 out front, and I'm going from 1 to 9. So I have 1/3 u to the 3/2 going from 1 to 9. So I get 1/3 of 9 to the 3/2 minus 1/3 of 1 to the 3/2. Or you can just pull the 1/3 out too. Isn't that what we had over here? It's exactly the same, right? It's exactly the same as that step right there. It's just not going back to x's. We got that with just using u's. So then we still have our 26 over 3. So which way do you guys like better? The second one. And the reason I like the second one is because a lot of people will forget to do the numbers anyway. Like they'll do the first integration step and they'll get to here, like the blue box. But then they'll be like, oh, I'm done. And then they forget to like put the numbers in. Okay, so that's why I like changing it to u and then just finishing out the problem. All right, so let's try this next one. So we have 1 minus 4x as our u. So then du is going to be negative 4 dx. So we have negative 1/4 du equals dx. And then we want to know our u values as well. So we want to find u of 4 and u of 1. So we plug into here. So u of 4 is going to be 1 minus 4 times 4, which is negative 15. And u of 1 is going to be 1 minus 4 times 1, which is negative 3. So the 1 was replaced with negative 3, and the 4 was replaced by negative 15. Now that might bother some of you that it's like a bigger number to the smaller number. That's fine. You can make it negative if you want, or just leave it like that. I'm fine with you guys leaving it like that because it's going to work out in the end. So you can switch it if you want to or leave it. I'll just leave it. So we have 1 over u squared. So u to the negative 2 du, and we had that negative 1/4 from before, from the negative 1/4 du. All right, so I have my negative 1/4. I integrate my u to the negative 2. So I add 1 to the power, negative 1. 1 over negative 1 gives you still negative 1. And we go from negative 3 to negative 15. Then I would take that negative 1/4 times negative 1 and write it as 1/4. And that's where I usually just kind of keep it out front. I don't really write it for both of them. And then I'd say, okay, I have u to the negative 1, and I'm going to raise it, or I'm going to not raise it. I'm going to put in the negative 15 and the negative 3 and subtract them. So I have my 1 over u. That's what that is, right? And I'm plugging in negative 3 and negative 15. So I have my negative 1, or my positive 1/4. Lots of negatives in here. And then I have 1 over negative 15 minus 1 over negative 3.
How are you doing it? Trying to do each one of them individually?
Like with the 1/4, is that what you're saying?
Yeah.
You can leave the 1/4 with each one, or you can pull any constants that you have to the front.
Because we like did them individually.
Yeah, it doesn't matter which way.
So we could have done it like that.
Yep. So let's see. So I get negative 1 over 15, and I'm adding 1/3. So 5 over 5. So I get 4 over 15 in the end. You guys see it? So I have 1/4 times 4 over 15. So our answer should be 1 over 15. All right. Are you guys understanding this process? All right. So sometimes finding what to make your u can be a little bit tricky. So in this case, I have sine squared of 3x, cosine of 3x. Your u is not just 3x in this case. Okay, so any ideas on what we should make our u? You could make it sine squared of 3x. That's what I'm kind of hearing in the back. If you have sine squared of 3x, though, and you take the derivative, then you're going to have 2 sine of 3x times cosine of 3x, and you'd have that extra sine of 3x in there. So it can't be sine squared of 3x.
Sine of 3x, cosine of 3x?
Nope, it's not sine of 3x, cosine of 3x. Yeah, keep it simple. Just what? Just what? It's not just 3x either, because then we have sine squared times cosine squared, which we don't know.
Just cosine of 3x?
Close. It's not cosine of 3x,
Sine of 3x.
because then its du involves a sine of 3x, but we have 2 of them. So it's sine of 3x. So we're letting our u be sine of 3x, because when we take the derivative, we're going to have cosine of 3x times 3, and then the dx. Okay, so let's look at it. So that's good. We got our cosine of 3x dx there. And that 3, it doesn't bother us because that's just going to be a 1/3 du. So we're good there. What is the sine squared 3x being replaced with? U? Just u? U squared, right? Okay, so this was kind of equivalent to like our double chain. So it's like parentheses within parentheses. So like we had our sine of 3x, all in parentheses, all being squared, right? That's why it's our u. Okay, so now when we replace, we're like, okay, we got u squared. The cosine of 3x dx is replaced with the 1/3 and then a du.
Wait.
So when we integrate, we have our 1/3. We do u to the 3 and we gain another 1/3 plus c. So our answer is 1/9, whatever u was to the 3rd, plus c. So u was sine of 3x. Now you can write it like that, or you could be fancy, right, and write it the way we do in math. Sine cubed of 3x plus c, like that. You could write it like that as well. Either way. Ariana's done that like 6 times in this
So
problem.
like, are we not doing the
Okay. Sometimes it takes a little bit to simmer. All right, so this next one is really tricky. So there's a new thing that we're learning. So we have the U-Substitution. We haven't done one like this yet. What would your guess for the U be?
X.
Not just x. You never let U be x, actually, because then that's just changing your variables to U. Yeah, 2x plus minus 1. Yeah, the inside of the parentheses. But when we do du, it's like, oh, wait, I just get 2 dx. Now, sometimes that means that you can't use U-Substitution. But in this case, we still can use U-Substitution. It just is very strange. Okay, so we know this part is replaced by the square root of u. And we know the dx is replaced by 1/2 du, right? But then what about x? Ah, good. Okay, we look here and we're like, well, what is x? If I add the 1 over and I divide by 2, right, u plus 1 over 2, that's what x is. So we can rewrite. So do you guys see it? Sometimes you have a leftover x or like an x plus 4 or something like that. That's okay. Just solve for u, or solve for x. Take that equation that has u equals and solve for x. Rearrange it. So now when we replace, it doesn't look like it's going to be any better because it's still kind of complicated. It's like, okay, I got that x. That's going to be u plus 1 over 2. I got my square root of u. I got my dx is 1/2 du. And then students every year are like, but that's even like more complicated than the last one.
Why did you leave the u plus 1 over 2 like inside?
Because we still had that x that was inside the integral, and we needed to replace that x.
I know, but like the last one, like the cosine of 3x.
That was replaced by the 1/3 du.
Yeah, and you put it on the outside.
Well, the 1/3 I put on the outside, the du I put on the inside. Yeah, Ariana.
Can you bring out the 2 and make it like 1/4?
You could make it 1/4, so that's one thing. We're going to bring 1/4 out, and then I have my u plus 1 times square root of u. I'm going to write as u to the 1/2. Do we know how to integrate that? How do we integrate that?
Don't you have to boil it out first?
Yeah, we're going to multiply that in. So we're going to have my 1/4. I'm going to have u to the 3 over 2 plus u to the 1/2, and now it's set up so I can integrate. So the reason we have to do that is so we could write that as u to the 1/2. In the original problem, we cannot write 2x minus 1 to the 1/2 and know how to integrate that, right? That's what's involving the U-Substitution. So we have to change to u's to make it so it's a single term to the 1/2, not like a binomial to the 1/2. Do you guys see? So now we're going to do u to the 5 over 2 with a 2/5 out front. We still have our 1/4. So you can wait till the very end and do the 1/4, like do a big bracket if you want, or bring the 1/4 to each piece. It doesn't matter. So let's say we bring it to each piece. We'll do that. And then I have plus my u to the 3 over 2 with a 2/3, and it has the 1/4 as well. Plus c. So we have 2 over 20, which is 1 over 10, whatever u was. So u was 2x minus 1 to the 5 over 2 plus 2 over 12, which is 1/6, 2x minus 1 to the 3 over 2 plus c. That's our answer. And you could take the derivative and try to simplify it into the original. It ends up being the same. Okay. do I have any more of those? Maybe one more. Let's do one more like that where we have x's. I have to solve for them. So number 3 is just letting u be 8x because you actually know how to integrate secant squared of u. Let me write this one really quickly. And then we'll do number 4. Number 4 will be our last one. So this is our 1/3 and a 1/8. And then we get secant squared of u du. So think back to our derivatives drills. What do you take the derivative of in order to get secant squared of
Tangent.
x? Yeah, you need tangent, right? So if you're integrating secant squared u, it's going to be tangent of u. Its derivative is secant squared, right? So you're going to get 1/24 tangent of u plus c, which is 1/24 tangent of 8x plus c. All right, and then number 4 is one of those ones where you got to get the x by itself. So let's set up our u. What do you guys think u is for number 4? X minus 2. Du is just dx. So as we start to replace, we're like, okay, this part is good. We're square root of u there. This part is good. That's just du. And then we're like, uh-oh. X plus 2. Okay. So not a big deal. We just solve for x. We say, well, x,
Solve for
get the x by itself. It's going to be u plus 2, right? So get x in terms of u. So then what's x plus 2?
u plus 4.
Yeah, so x plus 2 is the u plus 2 plus another 2. It's u plus 4, right? That was the part right there. U plus 2 is x, right? So I have x plus 2, or x plus 2 is replaced by u plus 2 plus another 2. And then square root of u du. So we're going to have u plus 4 multiplied by u to the 1/2 du, which will be u to the 3/2 plus 4u to the 1/2, and then I integrate. So we're going to have u to the 5/2 with the 2/5 out front. Then we're going to have u to the 3/2 with the 2/3 out front and the 4 plus c. So our answer is going to be 2/5 x minus 2 to the 5/2 plus 8/3 x minus 2 to the 3/2 plus c. That's our answer.
2 is 2 to the
All right. So we pass out your